Hi guys, my name is Beth from My Tutoring Bee, and today we are going to be talking all about factoring. I'm going to give you some tools and tips to help you when you are factoring binomials and trinomials. So let's get started. So we're going to start off with just some common factors. So here I have x squared plus 2x, and what we're looking for here is we're trying to decide what can we factor out from each of these terms. Basically, what can we divide out of both of these terms? So if you know about the distributive property, this is basically the opposite of the distributive property. What can we divide out of both x squared and 2x? So that's going to be x. We can divide out an x from both of these. And the way that we write that is x out here to the side, and then whatever is left over inside that set of parentheses. So again, we're kind of doing that backwards distributive property. So x squared divided by x, that's going to get rid of one of these x's up in the numerator, leaving us with just x. And then 2x divided by x, the x's will cancel out, leaving us with just the plus 2. So there we go, we factored out an x from this binomial. So let's try another one with 4x plus 8. Again, we're trying to find out what we can divide out of each of these individual terms. And 4 can go into both 4x and 8, so that's what we're going to divide by. So we divide by 4 here, divide by 4 here, and the way we write it, again, is the 4 on the outside of the parentheses. And then inside is what's left over once we divide. So this 4 and this 4 cancel out, and we're just left with x from this first term. And 8 divided by 4 is 2, so we're left with plus 2. In this next expression, we have a trinomial. So the ones that we've done so far have been binomial, 2 terms. This one has 3 terms. So you can do just common factoring with trinomials if they all have something in common. So again, let's look at all of these terms, 3x squared plus 9x plus 6. What can we factor out, or what can we divide from all 3 of these terms? So that's going to be 3. So when we divide out 3, I'm going to write 3 outside of the set of parentheses. And then again, whatever is left over is what's going to stay inside the set of parentheses. So 3x squared divided by 3, the 3 is going to cancel out, and that's going to leave us with just x squared. The 9 in the 9x is going to cancel out with 3, can be divided by 3 times. So we're left with plus 3x. And then the 6 can be divided by 3, and that's 2. So we've got plus 2 left over here. So now I would like to point out here that this trinomial that we're left with inside the parentheses can further be factored. We're going to talk about how to factor trinomials in a slightly different way in the next step. So I'm going to leave this as is for now, but we can continue factoring that, and we'll come back to that in a little bit later. Okay, so now we are going back to binomials, but with this one, it's slightly different than the ones we've done so far because we can factor out both a number and a variable out of both of these terms. So what can we factor out? Let's just look at the numbers, the coefficients for right now. What can we factor out of 2 and 10? Both of those are divisible by 2, so that's what we're going to start with, dividing by 2. But then also, let's look now at the variables in each of these terms. We have 2 x's being multiplied together, that's the 2x squared that you see here. And then we have an x here that's being multiplied times the 10. So that means we can divide out an x from both of these terms as well. So we're going to, again, write that 2x is going to be outside of the set of parentheses. And then let's see what's left over. This 2 and 2 cancel out. This x and one of the x's from the numerator cancels out, so that leaves us with just x minus, we always keep the same sign here unless we're dividing by a negative number, which we haven't done so far. And then here, 10 divided by 2, that cancels out and becomes a 5. And then again, our x's cancel out completely, so we're just left with the 5 there. Great, so let's continue on to factoring trinomials into binomials, into 2 binomials. That's what we're going to do in this next section here. And basically what we're doing is, if you remember FOIL, first, outside, inside, last, when you are combining or multiplying together two binomials. This is the opposite of that. So we are taking that trinomial that we would get after FOILing two binomials and breaking it apart back into those two binomials. So we're just kind of going backwards from what you've learned previously about FOIL, how to FOIL binomials. So in order to start here, what we need to do is just, I like to go ahead and set up my two parentheses because I know I'm going to be able to, or at least I'm going to try to factor these into two binomials. So let's see what we can start off with. We're always going to start with the first term and see what we can break that down into. So now since we just have a simple x squared, remember that just means x times x. So that's what we're going to separate it out into. We're going to need an x here and an x here in the first terms of each of our binomials, because that is what goes along with, again, we're kind of going backwards from FOIL. So if we think about this as foiling it back together and multiplying these back together, how do we undo that? We're separating them into x and x. Okay, and then we're going to jump over here to the last term. We're going to worry about this 5x, this middle term, in a little bit. But what we want to focus on now is what factors make 6? So in other words, what two numbers can multiply together to give us a positive 6? So a lot of times some people will do like these big X things and they'll put a 6 up top and they'll put a 5 down here and they'll think, okay, what multiplies to make 6 and adds to make 5? If that method works for you, well, I'll actually talk about that. I have another video that talks about this method. But I find that what works best for me and for a lot of the students that I work with is I just make a T-chart with the factor up, I'm sorry, with the product up on top, and then the factors are going to go down here side by side. So let's think about what multiplies to make 6. I always like to start with 1 and the number itself. That's the easiest factors to identify. So we've got 1 and 6. Okay, and then what else makes 6? 2 and 3. But keep in mind that also -1 times -6 would give us a positive 6, right? And also -2 times -3 will give us a positive 6. So keep those in mind when you're doing these factors, because the signs are going to come into play with the many different types of factoring problems that you're going to see, and we'll get into some of those, of course, later on. But for right now, what we're trying to identify from all of these pairs of factors is, okay, which one of these, when I add them together, we know that they multiply to make positive 6, so we're good with that. Now our next step, now this is where we look at that second term in the middle of our trinomial and say, okay, when I add these pairs together, which one of them gives me a positive 5? That's what I'm looking for. Okay, so if we look through, I can see that 2 plus 3 would give me a positive 5. So that means since they're both positive numbers, I'm going to have one of these as x plus 2 and the other one as x plus 3. Okay. And of course, we can always check that by foiling them back together and seeing if we get that original trinomial that we started with. So let's do that just really quickly to check our work, basically. So our first terms, x times x, is x squared. Our outside terms, x times 3, is a positive 3x. Inside terms is 2 times x, so that's positive 2x. And then last terms, 2 times 3, is positive 6. When we combine our like terms here in the middle, we get x squared plus 5x plus 6. And that does match what we started with. So that's just sort of our little check to see if we factored these correctly. And these, I should say, are our factored binomials. Okay, great. Let's do another example. As you can see with this new trinomial that I have down here, it is almost exactly the same as what we just factored, except now we have a minus 5x as our second term in the trinomial. So let's see what happens when we try to factor this one. Again, we're going to go ahead and set up our two sets of parentheses for our binomials. And we know that x squared needs to be separated into x times x. And then again, we're going to jump over to this last term, the third term, and figure out what are our factors of 6. Now we just did this up here. We're going to do it again. 1 times 6, 2 times 3, and then we've got the negatives. Negative 1 times negative 6 and negative 2 times negative 3. So again, we're looking for that pair that will add up to this middle term. So which numbers, when I add them together, will give me a negative 5? So here, I've got that 2 plus 3 again, which gives me positive 5. But what I'm really looking for is negative 2 plus negative 3, because that will give me a negative 5. So those are the two that I'm going to use as the second part for each of the binomials. So now we've got x minus 2 times x minus 3. So you can see how this is similar in some ways to the problem we just did, but obviously different because of the negatives. And again, we could check those. We could multiply first, outside, inside, last. Let's go ahead and do that really quickly. X times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. And negative 2 times negative 3 does give us that positive 6. When we combine our like terms, we get x squared minus 5x plus 6. So that does match our original trinomial, so we know that we're good to go. Great, so now let's try another one. We've got x squared plus 9x minus 36. Again, we're just practicing factoring these out into two binomials. We are starting with x squared, so we're going to start with x and x as our first term in each of our binomials. All of the problems that we're trying today just have an x squared. I shouldn't say problems, all the trinomials that we're doing today just have an x squared as the initial term, and they don't have another coefficient other than 1. We'll get into problems like that in another video. This is just sort of to introduce you to how to deal with that second and third term when you're factoring. Okay, so we've got that x squared split up into x, and now we're going to jump over to the last term, and now we have a negative 36. So let's go ahead and set up our t-chart to find, that was not a very straight line, to find all of our factors that could give us a negative 36. So again, like I said before, I always like to start with 1 and the number itself. That is just the easiest factor to, pair of factors to come up with. So in order for it to be a negative though, I know 1 times 36 is 36, but in order to make that a negative, one of these numbers has to be negative. So it could be negative 1 times 36, or I could have 1 times negative 36. So I'm going to list both of those there. And then I like to just try the next factor. So I've tried 1 first. I know that works. That always works. Now let's see if 2 can go into 36. So negative 2 times positive 18 equals 36. And you can pause these and try to see if you can come up with all the factors of 36 and then rejoin me and see if you got them all. And then, of course, if we've got negative 2 and 18, then we can have the positive 2 and negative 18 version, right? Because that would also give us negative 36. Then I move on to 3. Can 3 go into 36? Yes, it can. So I'm going to try negative 3 times 12. That gives us 36, negative 36. And then the opposite version of that. So we've got positive 3 and negative 12. Now I'm going to try 4. 4 does work. For 36, 4 times 9, so negative 4 times positive 9. And we can also do positive 4 times negative 9. And then can we keep going from that? We've got 1, 2, 3, 4. How about 5? 5 can't go into 36 evenly. How about 6? 6 works. We can do negative 6 times positive 6, or they're the same number, so I'm not going to write it twice, but we could do positive 6 on this side and negative 6 on this side. So now that I like this T-chart because I can, as you can see, I've just gone down, I've gone through the numbers one by one, and once you reach either the same number or the next number in the series over on the other side, you know that you've gotten all of the factors. If you've tried every one by one, that's a great way to make sure you don't miss any of the factors, especially with larger numbers that have a lot of factors in them. Okay, so let's try to figure out which pair would add to give us +9. Keep in mind that when you are adding a positive and a negative number, what you're really doing is subtracting them or taking the difference between the two. So be careful here when you are adding negative and positive numbers together. I actually have another video that I did all about how to add and subtract negative and positive integers. So if you need some extra practice on that, check that out. I'll link it down below. So let's just go through. -1 plus 36, that gives us +35, right? So it gives us a positive number because the 36 is the positive number, so that has more weight to it. Here, if we added a a positive 1 and a -36, that would give us -35, right? Because even though, yes, I know +1 is larger than -36, however, what I mean by that is the larger number or the number that carries the most weight with it will wind up being the indicator of the sign that you need to use with your answer. So when we add up -2 plus 18, that gives us a +16. When we add up +2 plus -18, that gives us a -16, right? So you see how this works? Then we get a -3 plus a +12. That's going to give us a +9. So we've already found it right there. If we kept going with this, this would give us a -9, and we could keep adding up, but we actually already found our pair of numbers that we need for this particular problem. It's -3 and +12. So that's what I'm going to write as the second term in each of these binomials is -3 and +12. And again, we can FOIL those to determine if we got this right, and you can do that. So I'd encourage you to pause the video and FOIL those and see if you come up with the original trinomial. All right, let's try one more example with trinomials. So here we've got x squared minus x minus 72. So I'm going to set up those two sets of parentheses. And again, we're starting with an x squared as our first term, so we know we can split that up into x and x. X times x gives us x squared. So now we need to figure out what are the factors for -72. So let's go ahead and set up our t-chart. I know 72 has a lot of factors, so we're going to try to write these small so that I can fit them in here. So -72, again, we can start with the number itself times 1. Because it's a -72, I want to have one of these numbers negative, because negative times a positive gives us a negative answer. So we've got -1 times +72 or 1 times -72, right? And then we're just going to keep going down the line. How about 2? Well, 72 is an even number, so I know that 2 can go into 72 evenly. So I'm going to try to divide it by 2. 2 can go into 7 3 times with 1 left over, so that gives us a 12 here. And then 2 can go into 12 6 times, so 2 times 36 gives us 72. And again, just like in the last problem, pause the video, see if you can come up with all of the factors of 72, and then rejoin me and we'll see if we got them all. So we're going to do the opposite version of that with 2 and -36. Then I'm going to go to 3. I'm going to try 3. There's a trick with 3 to see if you can divide a number evenly by 3. If you add both of the digits up in the larger number that you're trying to divide, and that answer, that sum, is divisible by 3, then the larger number is divisible by 3. So if 7 plus 2 is 9, 9 is divisible by 3, so that means 72 is divisible by 3. So we know that 3 will work. Let's see how many times it can go in. So 3 can go into 7 2 times with 1 left over. So again, that's 12. And then 3 can go into 12 4 times. So that means 3 times 24 is 72, or negative 3 times 24 is negative 72. Then we're going to do it the opposite way with the negative 24. Okay, now I'm just going to keep going down the list. How about 4? Can 4 go into 72? Let's find out. So 4 can go into 7 one time with 3 left over, right? So then we can imagine this is 32. So then 4 can go into 32 8 times, so it can go in evenly. So we're going to make this a negative 4 times 18, and then 4 times negative 18. Let's keep going. 6. The trick with 6 is if both 2 and 3 are factors of a number, then 6 will also be a factor of that number. So it has to be both 2 and 3. It can't just be one or the other. It has to be both. So because I have both 2 and 3 as factors, I know 6 can work. Let's just figure out how many times it can go into 72. So 6 can go into 7 one time with 1 left over, and then 6 can go into 12 2 times. So 6 times 12 is 72. I'm going to write this the other way. And then 7 can't go into 72 because I know 7 times 11 is 77. 7 times 10 is 70, so it skips right over 72. So now let's try 8. Can 8 go into 72? 8 times 9 is 72, so let's write those two versions. Negative 8 times positive 9 and 8 times negative 9. And again, just like I said in the last example, now that we have gone all the way around, 9 would be the next number that I would try, but 9 is already here in my factor tree, so I know that I've gotten them all. I haven't missed any factors by accident. Okay, so 72 has a lot of factors. Let's see which one adds up to give us a negative 1, because remember this middle term is a 1. It's an understood 1. We don't always write the 1 with an x or with whatever variable we're using, but we are looking for negative 1 when we add up these factors. We know they all multiply to give us negative 72. Which one adds to give us negative 1? That's what we're looking for. So when you're looking for a smaller number like this, what you are going to tend to find is that the closer your numbers are together, the smaller your answer will be when you're subtracting. So when I look down here, I'm actually going to start down here at the bottom of my t-chart here. And if I add 8 plus negative 9, remember I'm actually subtracting the 2, so 9 minus 8 is 1, but then because the 9 is negative and that carries more weight to it, this is going to be a negative 1. So I've actually found my answer right there. I know that it's 8 and negative 9. Those are my two factors that I need. So that means we need a positive 8 and a negative 9 for our two binomials. Great, so I just want to show you one more example. Remember this problem over here when we first began, and I said that we can actually continue factoring with what's here inside the parentheses, so I'd like to show you what that looks like now. So again, we had 3x squared plus 9x plus 6, and we factored out a 3 from each of these terms, leaving us with 3 times x squared plus 3x plus 2. So now that we know how to factor trinomials in this way, what we just did in this section, we're going to do that with this section of this problem. So the 3 still gets dropped down. The 3 is still part of the problem, and I see that happen a lot with my students, is that they'll forget to bring that number down or sometimes that variable down. And then this part is what's going to get factored into those two binomials. So again, we're just looking at just this portion and we're going to try to factor that. So x squared, just like we've seen in the previous problems, we're going to factor into x and x. And then with 2 as our last term, that one's pretty easy to factor. There's only 2 factors of 2 since it's a prime number. 1 times 2 is the only way to multiply to make 2. So we can also think of it as 1 times 2 and negative 1 times negative 2, right? Because those would both give us a positive 2 when we multiply. However, when we look at our middle term here, our middle term is a positive 3, so which of these would add up to make a positive 3? it's got to be 1 and 2. So this has to be plus 1 and plus 2. Another thing that I'd like to point out here is that any time that our last term is positive, like in this one and this one, then both of our signs inside the binomials are going to be the same. Whether or not they're both positive or both negative, they're going to be the same if this last term is positive. If the last term is negative, like in this problem and this problem, then our signs are going to be opposite. One's going to be positive and one's going to be negative. Same with this. We can see one positive and one negative. And that's because that's the only way to multiply to get a negative term at the end there of the trinomial is by multiplying a negative times a positive. So just keep that in mind when you're trying to figure out and find all of your factors that will go into these binomials. I really hope that this video was helpful for you in determining factors, whether or not you're just doing a common factor or factoring trinomials into binomials. My next video is going to be all about factoring perfect square trinomials and difference of two squares, so please check that out. And of course, please don't forget to like and subscribe. I would love to see your comments down below. I try to respond to the comments as much as possible, so please let me know if this was helpful for you or what you would like to see next from me. Thanks.